In this video, I'll be sharing with you this design, which is a drop ceiling design that has an undulated surface. It has triangulated subdivisions, and it has these extruded panels on the inside. So I'll be going over all of the steps in detail. So if you want to learn about parametric design, parametric modeling for architecture. So thank you very much for being here, and let's jump into the tutorial. Alright, so the first thing we're going to create is the base surface for this script. So we'll start by going to a point. So we'll go here to construct point. This will give us a parametric point that we can change. We can also route this through an empty point component, so we can change the location of that point. And now we can bring in the reference plane that we'll be using for the base geometry. So we'll go here to an XY plane. And this is the reference that we'll be using to create the plane surface. So with this plane surface, now we can change the size, and we'll bring in two sliders so we can change the overall size. So here we have it as a square subdivision or a square geometry, but we could change the sliders here to make it any size we want. Now we're going to divide this into points. So we'll go here to divide surface. And if you're seeing things a little bit different here, it's because I have my display as draw icons, fancy wires, and full names. So this way you can see all of the inputs and outputs. So now here we can change the overall subdivision in the U and V, which is a grid that is created on the surface, and by default it's already 10 by 10, but now we can change the number of subdivisions here. Now we can use these points, and we're going to move them up randomly so we can create an undulated surface. So let's go here to a move component. So we'll be moving those points in the Z direction. And we'll be using a component called random, which will give us a random set of numbers. We just have to plug in some parameters, which are going to be the range, which is the start and end. So you can say random points between 1 and 10, and you'll get random numbers between those two. And then the number is going to be how many random numbers you want. And seed is more random solutions to the range and number. So now to figure this out, we're going to flatten the output of the points. This way we have it set as one long list, both for the move and also for the list length, which will tell us how many points we have. So we know we have 35, and this will give us a number that we can use 35 as the number. The range is going to be construct domain. And this will give us the smallest and largest number that we could use. So we'll go here to 1.0. Actually, let's do, say, 12.0. And we'll copy this twice. We just have to make sure that we have a difference of numbers. So we have a smaller number, a larger number, and we can plug this into the range. So as you can see here, we have 35, that's from this number, 35 different numbers that range between 2.65 and 16.25. Now we can plug those into the Z move, and notice that it moves those up randomly for all of those points. And also, let's not forget to use the seed, which will give us basically different solutions to those random movements. So I'll bring this back down to 0. We can always change that if we don't like the way that the surface is being created. And let's hide the original points. Now we're going to create a surface that goes through all of those points. So to do this, we'll go to a surface from points. We'll plug in the points into the point input, and the U count is going to be how many subdivisions we have in the U direction. So if we look here, we have 6, and here we have 1, 2, 3, 4, 5, 6, 7. So we actually have to add one more. So let's go here to +1, and this will give us a addition component that already has a 1 on the B, so it's going to add whatever number by 1. So we'll go to 6 plus 1 and plug this into the U count. Now notice that with this, we're already getting an undulated surface, but the surface doesn't go exactly through the points. So there's two different options. You can have it be as a reference of how the surface is created, not necessarily touching it, but you can also do it by interpolate set boolean to true, and that will make sure that every single one of those points is touched by the surface, which makes the undulations a little bit more drastic. So let's now go back to that original plane and hide it. And if we want to see it a little bit better, we can also bring in a custom preview and a color swatch to see the geometry and with some color and not basically seeing through it. So now that we have this, we can change a few things. Here in the script, we can change the seed, and this will give us a different undulated surface. So this is useful if you don't like exactly what you get the first time. And you can also control how much this undulates by the subdivisions. So if you have 2, or if you have more, it's going to be more, it's going to have way more undulations. And we also have the ability to change the maximum and the minimum. So what I'll do for now is decrease the number of points. Let's see if we do 3 in each direction. And let's increase the amount here. Okay, so now that we have this, now we're going to subdivide it. So with this surface, I'll first hide the wire on this one, just so we have a clean script here. You can always select it and see where it comes from. It basically comes from the U and the +1. So now let's move this over to the side. Let's unplug it. We'll be using that again. And now let's subdivide this. So when you subdivide a surface, there are different ways that we can do it. I will be using Lunchbox, and I'll be using so that's a plugin that you can download and install completely for free. Or you can use Isotrim, which is one that already comes in with Grasshopper. I'll be using Lunchbox and Triangulate. For triangle panels B, we'll plug in the surface into the surface input. And now we can change the U and V subdivision. So once again, bring in 2 sliders. I'll slide the slider here, tap Alt, and create 2. Now we can change how many subdivisions we have in both directions. So let's hide that undulated surface. And now with this, we have the triangulated surface, which I wanted to use because it's going to be our base geometry for creating basically a drop ceiling. So this is a design that I wanted to explore here. So now that we have the triangulated subdivision, now we're going to take these panels and offset them to the inside. So we're going to go to offset on surface and plug in both the panels into the curve and the surface. Now the distance is going to be how far the panels are offset from that center line. So I'll take these and offset them by, just go to 1.5. And the more decimal points, you have a little bit more precision. Now what I'm seeing here is that this one is actually taking too long. There's another way to create this by going to offset curve, using these panels as the input and these panels as plane. Now we can offset by 1.5, but as you can see, it's offsetting to the outside. So we actually need to bring in a negative component and offset this to the inside. This is going to be creating the frame that we'll be using to create the suspended ceiling. So now we'll copy this over and unplug the distance, and we'll go to distance number of 0. So right click on the input, set number, we'll go to 0. This way we can use this one and this one to create the frame, which we'll do by creating a loft between those two. And now we can hide these panels. So that loft is taking that outside and inside and joining them together, creating this surface. Now we can take the inside panels and we can get the center. So we'll go to an area component, giving us the center of those triangles. And we'll be using those and moving them up vertically. So we'll go to move. The centroid in the Z direction. And we'll use a component slider. So we'll go here to 12.000. And then hide the original centroid. So now 12 is a little bit too much, so we can decrease this. Now let's connect the line segments and the point, and we'll bring in the component called extrude to point. Now, as you can see here, this is a dashed wire, which means that it's a grafted set. And that's perfect because the center of each is organized with the center of each centroid here. So this will allow us to take the base, which is going to be these rectangles, and extrude them up to each point. So now let's hide all of this, and let's add some color to it so we can see it a little bit better here. So you can visualize this being like a ceiling, and that is connected to these planes that are basically the grid that creates the triangulated subdivisions, and then the acoustical panels that are extruded to the inside. And you could add lights and whatever type of things you want to that. You could do speakers and stuff like that. So with that being said, let's plug in the extrusions into the custom preview. And let's add color to the frame. So I'll copy that and change the color to a dark gray. I do like to route these through a geometry component because this is technically the end of the script. Let's go here to geometry. I like to group this one to add some color to it. Now my default color is green, so I know that that's basically the output, and I'll just copy this over and do the same thing for this one. Now I can hide these two and just know that those are the outputs, and then hide the wire display for the custom preview here. So just keeping things organized and neat, so then anyone can use this script again. Now, as you can see, this is just one type of subdivision. I've used triangulated panels. We can change how drastic this is by changing the subdivisions here. And maybe not 28 inches, but maybe just 12. And you can change the subdivision type. So we have triangles here. If you wanted to, you could use isotrim or a rectangle subdivision. So let's go here to let's go to diamond. And I'll double click here on this output and plug in both diamond panels. So I'm double clicking to create a relay, which what it does is it maintains all of the outputs in one location. And we'll plug both of these in and see that. Let's see if we'll flatten this one. It's just doing the outside one. So let's see if we'll just use the, oh, the offset doesn't work with that one because it's not triangulated. So basically it has to be a plane surface that it creates in the middle. So if we use triangulated panels like this one, do that again. It will work with this one as well. So there are many different ways that you can subdivide this. For now, I'll keep it with this one. And now let's also move this down. Let's say to 2. So with that being said, let's go back and organize this. So I'll group this so you can change the location. We'll also be able to change the surface input. So I'll do it like this. I'm basically now organizing it and making sure that it can be used with different inputs. So now this surface does have to be one that is organized in the XY plane. The reason why is because we're moving these points in the Z direction, which means that they're moving up and down. If you put this over to the side, then you need to change this vector to be perpendicular to that surface. So just keep that in mind. I'll group this and hide it. So this is going to be X. This is going to be Y. Let's make them cap blocks. I like to group them to know that those are sliders I can change. And then here we'll go to U. And then V. This is going to be minimum and maximum. So if we want to do the opposite, you could do that as well. This is going to be seed, which is basically, you'll see here, changing that to be a different options for the same numbers. We'll hide some of these and go here to U, SRF for div, for division, and then U, and then division B. The distance on this one is going to be frame. And if it's 1.5 from here to here, from here to here is 1.5. Overall, it's going to be 3. So that's just something else to keep in mind. And then here is going to be div depth. And we already have the outputs grouped in. So now this is ready for anyone that wants to use it. I will have this available on my website for a limited time. But overall, I just wanted to share all of the steps necessary to create something like this, which can be used in many different applications. In this particular application is going to be a ceiling, drop ceiling design, but you can visualize this being also a wall design, or even an undulated light design. So hopefully that taught you a few new tricks, a few new tips. If you have any questions, let me know in the comments below. Thank you very much for being here, and I hope to see you in the next one.